And welcome back to Stormworks Basics. This is going to be a modular engine tutorial for 2023. And so let's go ahead and get started. Right, so modular engine's a pretty in-depth topic, so I'll have some other parts to this, but we'll go ahead and we'll start with just the very basics in this video and get it up and running. So we're going to start by looking over the parts. So I just typed in mod for modular. We have air manifold, modular engine alternator, clutches, 1x1, 3x3, 5x5, coolant manifold, crankshafts. We have a 1x1, 3x3, and a 5x5. We also have a 3x1. We have converters, a crankshaft converter, 3-to-1, and a 5-to-3. We have cylinders, 1x1, 3x3, and 5x5. We have belt drives, which run our belt-driven accessories. So anything you see with this loop, that's a belt that's driven off your belt drive. Next, we have exhaust manifolds, a corner piece, and a straight. Modular engine fluid pump. We have flywheels, 1x1, 3x3, and 5x5. We have a modular engine fuel manifold. We have manifolds, which allow us to hook the different banks together. We have a modular engine starter, and we have a modular engine temperature sensor, which I really don't use. I just use the composite. So let's go ahead and get started. So really quickly, we want to keep in mind that the different parts in Stormworks have different shapes, and that tells you what to connect. You often see people connecting things incorrectly when they first start, and then they ask why their engine's not running. It's because the like parts are often misaligned. So if we look at the parts here, we have an octagon with a shaft. That's the center shaft of your crankshaft. Then we have these squares with these 4 diamonds in there. And so you want to make sure you're matching the parts up. So let's go ahead and grab a 1x1 cylinder. So we'll do this with a 1x1. The nice thing with the modular engines is everything pretty much, the vast majority of it is, you know, can work with the different sized engines. You just have to change them out. So if we look at the bottom of the cylinder here, you see we have that square with the 4 diamonds. So again, it has to match up with the square with the 4 diamonds. On the side, you notice we get a new shape. We get the square with the 4 holes in it. All right, so for example, these 2 cylinders can match up. They'll pass fluid and air through each other, but you have to match up the correct part. All right, so that's the beginnings. So next thing we want to do is we want to put on a belt drive, and the belt drive is going to run our belt-driven accessories. So if we turn this around, as you can see, we have the octagon. And it also introduces another shape, the rectangle with the 4 diamonds on it. So again, this is a belt drive, so it connects with belt-driven parts. So first one we'll put on there is a starter. So an engine needs a starter. You'll see some of the old tutorials, people using electric motors. Not a fan of that. You should have no problem with starters. Sometimes with the bigger engines, you need multiple starters, but some of my largest engines, my 5x5s or my like 8-cylinder 3x3s, they might only need 2 or 3 starters. People are often trying to start them with the clutches fully engaged, and that's why they're having issues. So put the starter on there first. Next thing I'll put on is an alternator. I often will put on 2 just because I have the space, but it's up to you. So let's go ahead and we'll just put it on 1 for now. All right, and so that's an alternator. Alternator generates electricity. So when you're doing these, you'll notice they will fit like this, but make sure the belt is over the belt crank there, the belt crank. And so then we also we can use this pump. This pump is not great. If you, I will link up in the right here. Or actually, we'll link it right here in the left. You'll have my cooling tutorial that shows the different parts. You know, it goes through these pumps. It goes through the small pumps, large pumps. It goes through what's giving you the best flow rates, and that will show you the best ways to cool your engine. So I'm not going to go into that part in this. You'll see it in that video. And so we have that connected. So let's go ahead and let's just double this up. Let's make it 2. So the nice thing with modular engines is, you know, let's look at the old engine. So these are the old engines. So, you know, if I was to take a small engine, that has a certain power, it has a certain size. But the problem is if you get to the point where you need a bigger engine, well, you need at least that much space. You need a bigger engine still, you need that much space. And so you have to completely tear apart and redesign your build. The nice thing with these is, let's say you need double the power. Very simple. We now have double the power. Let's say you need, you know, double the power again. We have double the power. Let's say you need double the power again, or It'd be 50% more power now. We do that. And then we could even delete this out here. And we could add 2 more cylinders on here. And we'd increase the power even more. Now, in order to make these work and these quote-unquote talk to each other, you need to put in manifold pieces. So here you have manifolds. So what I mean by talk to each other is we have our air manifold here. So let's plug that in. And so let's put that on. And let's put over here the fuel manifold. We'll take these off in a second, but I'll just kind of show you what the manifold pieces, these 3 pieces here, do. So if we take our fuel manifold, so each engine needs 1 air manifold and 1 fuel manifold. You'll see old guides where they're doubling up the air manifolds to 1 fuel manifold. You don't need that. So now the issue here is, so remember, like parts are going to communicate with each other and connect. So we need to have this square with the 4 circles plugged into another square with the 4 circles, or they're not going to pass information. So for example, if we look at this top bank, and when I talk about banks, bank is going to be the sets of pistons. So this bank here of 2 pistons, that has a air manifold on it and a fuel manifold on it. These will pass air and fuel through one another, but these will get nothing. So if you don't connect these with a manifold, you're not going to get any air or fuel to any of these other banks. So to connect your banks, you need manifold pieces. And so you can connect that. Now this top bank, the air can go through here, into this bank, and that's connected. In order to get to this bank, you need to go there. And you don't need to go all the way around. You can go 3/4 of the way through like that. And this one will push the air and fuel through there. This one will push the air and fuel through here, and then through there. So that's the nice thing about modular engines. You want to make it even bigger, make it bigger, bigger, bigger. You can just keep adding parts. All right, so let's go ahead, and I'm going to keep this kind of on the simplistic side there. So the nice thing, again, with modules is it all, you can just add cylinders to it as long as you're connecting banks and stuff, and it works. And so if you need a little bit bigger engine, you need 50% more power, you add 1 more cylinder. You need 100% more power, add 2 more cylinders, in this case. All right, so the next part that we most certainly need is, and I took it off, but I'm going to add it back on, is an air manifold. All right, so the air manifold supplies air to your engine. So for combustion, you need air, you need fuel, and you need a source of ignition. Now, the source of ignition is inherent inside of the engine. You don't have to do that in game. In real life, you'd have to do spark plugs, or you'd have to do a compression, and for diesel, you'd be doing compression. But you don't need to do that. So we'll put that there. And then over here, I'm going to go ahead and I will put on the, let's put the fuel looking down like that. All right, so we have air and fuel. Now, the next thing we definitely need is exhaust. And so we have an exhaust corner manifold. Again, the parts have to connect to like shapes. So if we turn this, you notice it's the square with 4 holes. Square with 4 holes has to go on a square with 4 holes. But now look at this. That is a regular octagon. See how it looks like a pipe? So from there on, you need to go pipes. You only do 1 of these. You'll see a lot of new people, they'll do this. They'll stack these like this and say, my engine isn't running, and your engine isn't running because you're not connecting like parts, right? This square with 4 holes does not connect to this octagon here. And so, of course, that's not going to work. So you can put a pipe. So this allows you to pipe it wherever you want. So let's do a tall stack just to show how we can pipe it. You can also put in a catalytic converter if you want. Catalytic converter will cut down on smoke. But the thing you want to notice with a catalytic converter is make sure you read this. It has exhaust out. The other side, if we cut this, you'll notice it says exhaust in. So make sure it's going the right way. The way I tend to do it is if I go in here and I want to put a cat on there, you want to put the exhaust in like this. So if we aim on the downstream part, and then the upstream part's that. Now, if we type in exhaust, we get an exhaust pipe. We can put that on there if we like, but we can put any sort of fluid outlet. So we could also put on a ram. That would allow it out. So anything that will allow fluid out, we can put on there. So we don't just need the exhaust pipe. So, you'll see people putting rams on there for RP and aesthetics. They'll put that on if they like. You can put whatever you like. So we're just going to stick with the standard fluid exhaust on there. So that will exhaust it. So we have air, fuel, and exhaust. And those are the three components that we definitely need in order to have this engine run. Next, this is optional. We'll talk about flywheels. Flywheels, what they do is, so let's talk a little bit of physics. So you have an object at rest tends to stay at rest, an object in motion tends to stay in motion. So if you're, what a flywheel is it's a large heavy weight, and it's a circular heavy weight. And so this adds mass to the engine. This makes it harder to start the engine, right? The object at rest wants to stay at rest. So if you're adding a big heavy flywheel, that takes longer to get started, but it also takes longer to get slowed down. An object in motion tends to stay in motion. So flywheels tend to be good for operations that, for example, flywheels are good for cars, flywheels are good for trucks especially. You want a lot of flywheel in a truck. That helps it maintain its momentum, that helps it, keep its torque. For example, on a large ship, you're going to want a flywheel. It's going to take longer for it to change speed, but for the most of the time, the ship is going to stay at the same constant speed. Now, applications where you don't want this, airplanes, and helicopters, you really don't. Theoretically, helicopter you could, but you really don't want to. Airplanes and helicopters, you tend to want to be able to, or need to be able to change the speed of your engine quickly. Again, remember, the flywheel is helping it conserve momentum. It's a tool for conservation of momentum. When you want to change your engine speed quickly, you don't want to conserve momentum. You want to be able to change that momentum. You want it to be dynamic. You want to be able to change it. This is more static. This tries to keep the RPS at the same value all the time because it weighs more. And so in an airplane, you tend not to want to use a flywheel. All right, so next thing we need is, let's go back to mod for modular, and we need a clutch. So again, let's look at the parts here. We have an octagon with a shaft. Make sure you hooked up the octagon with the shaft to the octagon with a shaft. And on the other side, you notice just a standard octagon. That can go to a pipe. So this could go out to a wheel. You can send that out like a drive shaft. You want to put a wheel on there, you can. Let's just stick a wheel on there. Stick a 3x3 wheel in the end. All right, and so that shows you what this is. And the first example will be a car. All right, so that kind of gets us started here. The other part we want to get going on here is a coolant manifold. Now, again, I will reference the video. Go ahead to that cooling video. I go through the different types and what tends to be best. And it's mostly about flow rate. If you have high oscillation in your flow rate, you're not getting good water passage through there. Another thing to note, you'll see in a lot of old tutorials that are outdated and do not work, and people still look at these old tutorials. That's why I said this is for 2023 when I started the video, was they used to tell you to put tanks in line with your coolant systems. Do not put tanks. Tanks will rob, they'll rob your water, and then you will actually end up running oscillating flow rates. You don't want that. Your engine will spawn, or your coolant manifold will spawn with water. If you're running really long pipe sections, you're going to need boost pumps and things like that, but we're not going to do that in this. We're just going to do something simple. Now, let's look at this modular engine fluid pump. If we put a pipe to it, you see it says fluid in. So that's our inside, all right? And so what we want to do is we need to take the water. The water is going to come out of here. If you look at this, you'll see it says coolant A. The other side says coolant B. If it says in, it has to be in. If it says out, it has to be out. If it says A and B, it can go either way. So you can flow water this way through here if you wanted, or this way. You can flip it around. It doesn't matter. All right. And so the next thing we have here is fluid out. All right. So let's go ahead and we'll put that there like so. All right. And what I'm going to do here is I'm going to grab a radiator. You'll see a bunch of different radiators here. This is the old fluid heat radiator. This still works perfectly fine. These two here are the most efficient means of cooling in game. You'll see a lot of people say, oh, just use an electric radiator. It's up to you, but these are most efficient. You tend not to need these in a lot of, unless you're running at super high RPS in a car or truck. For example, my Mac Pinnacle, I forgot to hook up the radiator, and it never overheated because I have it geared properly. I have it very low RPS. It never gets hot enough, and you might get a good solid long run on a highway in the arid biome where the temperature is up. You might get a couple miles where you're going at full throttle, but generally, every time you take a turn, you're going to let off a little bit. That's helping the engine to cool. It's not like a plane or a boat that is constantly at full throttle all the time. They tend to have their throttles pulled back, and that means you don't need all that much cooling. So you could go with this radiator. Let's just go by a 3x3. This is the second most efficient in game, so we'll go with that. All right, so let's look at it really quick here. So again, let's put our pipe on there and we see fluid B, fluid A, so it doesn't matter. It just has to go in one side and out the other. All right, so I'm just going to grab it. I'm going to cut it and I'll rotate it through here so that it will line up with my piping. All right, so let's go ahead and line that up with the piping here. And so that's going to go in there. So let's paste it and we'll merge it. All right, so let's talk our loop again. It's going to go through here. That's the fluid in. It's going to come out the fluid out. It's going to go in through the radiator. It's going to come out the other side of the radiator. And now we need it to go back up and in the top of this coolant manifold to circulate the water. So the engine is hot. There's water passing through the jacket. It goes through the coolant manifold. The hot water comes down and through the radiator. It goes through these fins in real life. Air is passed over the fins. The water passes its heat to the metal in the fins. The air takes that heat from the metal fins and it puts it off into the atmosphere. So that's how it works in real life, and that's how it's simulated in game. So again, things aren't perfect, aren't exactly the same in game as they are in real life. But if you understand some of the real life concepts, you tend to do pretty well. So we have to make a loop here. So again, comes down through the radiator, back up through, and through the coolant manifold. Now, the more these coolant manifolds you add, the better. You're going to want independent radiators, though. Putting them in series, one after the other, doesn't really help all that much. Again, watch that coolant video. That's going to help. All right, so we have that connected. So that's our cooling. Next thing we want to do is air and fuel. And so let's go ahead and we're going to put a seat and a microcontroller. So let's grab a seat. So this is going to simulate a car. So we're just going to do a driver's seat. Yeah, we'll stick it right here. All right, and then the next thing I'm going to do is a microcontroller. So I have one I just call blank, and then I can change it from there. So we're going to make a custom ECU right now. So you'll see everybody and their brother, they'll take ECUs off the workshop, and that's fine. You want to take this ECU off the workshop, be my guest. But I tend to make a new one almost every time, or at least highly modify it and Frankenstein every one for a new vehicle. And you'll see why. Somebody will grab an ECU off the workshop, they'll hook it up to their engine and say, it's not working right. And often it's because your engine isn't exactly the same as the way the person had it. And so that would be why. And so we'll kind of get into some of that. All right, so we'll just call this Stormworks Basics engine part 1. Okay. And so let's go ahead and we'll just make this a little bit on the big side here. And let's start adding some nodes. So, all right, so there are some things I know I need. And so we're going to go kind of simple mode to start with, and then we'll get a little bit more complex. So the first one I want to do is a number input. They don't have to be in this order, but number input RPS. All right, that's going to be a number output. That's going to be air manifold. And so generally my labeling is not this good when I'm doing it for myself because I know what I'm talking, I know what I meant. So this will be a little bit better so that you can find where they connect to if you wish to take it off the workshop. So air manifold, fuel manifold. We're going to do a number output. Let's see, coolant pump. And we're going to do an output here, radiator. All right, radiator. Let's add another node here. We're going to go ahead. We're going to take a composite input. That's going to be engine. All right. Let's see. We need a number output clutch. We need a number output alternator. And I'm going to call it alternator clutch because the alternator has a clutch. And we'll go through what a clutch is here in a second. I also have an auto clutch video that you can look at as well. All right, so let's go ahead and we'll start connecting this. So one thing I start to do too is where these spawn, I tend to grab them and move them down and then work below them so that they always spawn above. So it's just kind of a little thing to do. So let's start lining these up. All right, so we're going to go kind of easy mode. We're going to use a PID. PIDs are so powerful, the earlier you learn them in game, the better off you're going to be. And so I'm actually going to add a node that I want here. So I'm also going to add a node. This is going to be for tuning your p-value of your PID. You'll see, again, people will take something off the workshop. They'll hook it up to their engine, expecting the ECU to automatically know how their engine's supposed to function, and it won't work right, and then they're back in the discussions asking for questions. That's why this will be a little bit longer video. We're going to go into some detail. Instead of somebody watching a 5-minute tutorial and then spending 2 hours asking questions on forums, hopefully this will answer most of your questions. So this is going to be p-value. All right, and so that'll be in there too. And as you can see, that spawns up here so that I can see it. All right, so let's go ahead and start setting this up. All right, and I need another one. Let's put another node in there. Let's do seat. We're going to do most of this control from the seat, so that's going to be input from seat. All right, good. So that's also up here now. All right, so let's go ahead and let's get crack-a-lacking on this. All right, so RPS is one of our important things here, and so I pretty much exclusively, so I typed in PID, pretty much exclusively used advanced PIDs at this point. I don't ever use the other one, and the benefit of that is I can take an external signal, external value here. I can take this p-value, I can hook up a keypad to my microcontroller, and then I can change the p-value on the fly as I want to. So we're going to go through the top number is the set point. That is what you want it to be. And so we're going to set that as our WS on our seat. That's going to be like us pushing our accelerator pedal. We're going to say, hey, give me more, give me less power. That's going to be our set point. That's what number we want. So if you said, hey, I want 5 feet, and so you put in 5 on the top, and then it reads your current altitude, and your current altitude is 0 feet, well, the number is going to go up. If you're at 10 feet and you have it set at 5, it's going to go down. So your set point, we'll do in a second, the RPS of your engine is going to be your process variable. So it's varying what you set to what it's reading. And it says, okay, you want 30 RPS. Okay, you're at 10 RPS. I need to go up. Okay, you want 5 RPS. You're at 10 RPS. Okay, I need to go down. All right. So the next thing we're going to do is we're going to go to the seat here. All right, and we're going to go ahead and we're going to read a number. I know off the top of my head, you can get this off the seat. I'll show you in a second. 2 is WS. So if I plug this in, you'll see some people do this. They just plug it in. This will give you a 0 or a 1. Well, that doesn't really do anything for me. What I care about in game is RPS. Okay, and then as you start going into gearing, what you're doing is you're trying to convert RPSs, so it's best to set your RPS to start with. And so the first thing we're going to do here is we'll do a little function. So I just take the one node function here. And so when I press W all the way down and it goes to its max value, that's 1. So then I have to decide, well, how high do I want this to rev? So let's say I want this to rev up to 20 RPS. So all I have to do is X times 20 RPS. And now when I press W and it goes all the way to 1, it's going to go 1 times 20. It's going to say, hey, man, give me 20 RPS. So my set point is going to be 20. All right, if I let off the accelerator some and it's at 15, it's going to say, hey, man, give me 15 RPS. So that's going to then have the PID decide whether it goes up or down. All right, so that is our set point. I'm actually going to just do this so these you can see them all. I'm going to go like this so that they're a little bit easier to see. I tend to kind of stick all mine together. Makes it a little harder to see, but, you know, I'm used to it. So make it a little bit prettier for you guys. All right, so that's going to do my seat. Now, if I press the S key, it's going to go negative. All right, if it goes negative, then that's going to kill my engine, right? Negative fuel means shuts it off. Negative air means shuts the engine off. So we want to clamp this. All right, so if we click on this, we get an add-on. It's clamp within X and Y. You can set this if you want, so you could do, you could set that up. The other way you can do that is if you want to just take a clamp, and we'll do it this way. I'm trying to make it easy so you guys can follow this, so I don't want you to get bogged down and confused in formulas. So let's go ahead and we'll do it with a regular clamp here. So again, just search for clamp if you need to. And we're going to go into the clamp here. Now, again, like I said, you don't want to press the S key and have this kill your engine, right? Because a negative fuel value is going to kill your engine. A negative air value is going to kill your engine. So what you want to do here is you want to set your idle, which is the lowest you want this engine to run. So the engine has to run at least 2.5 RPS to keep running. So what I tend to do is let's go to something like, oh, I don't know, 4. It could be 3 or 4. And so the low value, the minimum value is I want 4 RPS to be my minimum value. My maximum value, I want it to be 20 or whatever I set here. So this can only go up to 20. So I could go 100 here, but this would probably confuse you guys because it will still only go to 20 because the max number that's going to go through here is 20. So I tend to set these both the same just to remind myself. And then this will connect there. So what this is doing is, again, I press W all the way up. That gives me a 1. 1 times 20 is 20. That's within the clamp. It puts a 20 through. It says, hey, we're at 5. It revs the engine up, and it gives us more power, all right, and more speed. All right, so next thing we need is I'm going to go off the seat, and let's make the 6-key starter engine. So all I'm going to do here is I'm going to read on-off. And we'll make the number 6 on there starter engine. So let's make that 6, and I'll plug that into the PID. So I'll go through the nodes really quick. Set point, process variable, proportional gain, integral gain, and derivative gain. I tend to just work with the p-value. A lot of people are adamant to put in the I and the D. You want a super small number for I, so 0 works well for me. D just gives you a little oscillation. I really don't need it with this engine controller. It doesn't have to be that precise. I can do it all with the p-value. If you want to play with the others, knock yourself out, but we can do it with just the p, and that's a lot simpler. All right, so I'm going to go back to design. I'm going to add another node. Did I put one in? I did not. Let's put in an output, and this is going to be our starter. Okay. And so let's go, and we want, so you'll see this with a lot of new players. They will leave their starter on. You'll hear it click, 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 click as they're driving. And so it's actually the first question they'll ask on Reddit is, why is my battery always dying? And the battery is always dying, and most people will answer with this because this seems to be very common, is they left their starter on. And so your starter will automatically shut off generally when you let go of the key. And so you want the same thing here. And so what we're going to do is we're going to have this not only automatically shut the starter off, but it will automatically restart the engine in case we stall it. All right. And so what we want to do here is we're going to start with an AND. So type in AND. All right. And we want to do a less than. All right. And so we're going to connect the less than RPS. So if the RPS is less than, and the number I tend to use is 2.5. So I think you need just at 2 to get this, to get the engine to kick is at 2 RPS. So I use 2.5, so a little bit higher. And if I turn on 6, and if the RPS is less than 2.5, all right, so I'm just trying to make these where everybody can see them. All right. Then I want to click on my starter. And that's not my starter. My starter's up here. That's my radiator. All right. So let's walk our way through this. So what I'm going to do is press the 6 key. All right. Now the engine's going to be off. So if the engine's off, right, the RPS is less than 2.5. So if 6 is on and the engine is less than 2.5, it's going to kick the starter on. The second that this engine gets above 2.5, which it should, because remember we set our idle at 4, then that should cause the starter to come on and start the engine. Well, let's say we stall the engine. Let's say we get the engine, we kick down, and the engine goes below 2.5. It'll automatically restart. We don't have to press the key again. All right, so that's how I generally run those. All right, so the next thing we want to do is I'm going to clamp out the end of it too. So I want to take another clamp, and I'm going to stick it here at the other end of the PID. Now I want the PID to read out a maximum value of 1, which is the most air we can put in there. Now we can supercharge it. We're not going to go into supercharge in this video, but for all intents and purposes in this video, the maximum amount of air we can put in there is a value of 1. All right. Now the minimum number, I did this before, so I know off the top of my head, but if this is 0, what will happen is the p-value, the PID will often go below 0. Well, what's that do? Shut your engine off. So you're also going to set your idle here, but we'll do that later. All right, so I'm just going to do 0, 1 for now. Now we can take our air manifold, and now we need more air than fuel. All right, so this is going to go directly into air. Now, we need about half. We're going to go simple mode here. We're not going to talk stoichiometry. We're not going to have this automate. We're just going to go super simple to start with, and then in later videos, we'll go through stoichiometry. So what we want to do is we want to take this node, and we want to go to the function here. Now we want about half as much air. Oh, I'm sorry. We want half as much fuel as we have air. So all we have to do is x times 0.5. Now you see some people will do x divided by 2. It's the same thing, just two different ways to do the same thing. So I tend to do x times 0.5. All right, so there's x times 0.5. So if I send a 1 to the air manifold, it's going to give me a max value of 5 to the fuel manifold. So fuel manifold is going to go in there. This is a very simple way to do it. Now, the stoichiometric equations make it a little bit better because as you raise in temperature, you want to change your air-fuel mixture. As you it makes it. You can also add things like superchargers that force more air in. You can do things like scoops that force more air in. Well, the more air you put in, the more fuel you can put in. It automatically does that. We're not going into that in this video. We're going to keep it really simple here. All right, so that's all in there. All right, so we have an engine that should be pretty close to starting, if not ready. I believe we are ready to start. So let's go ahead and get started. So let's update this. And let's go ahead in here and start connecting. So we're going to go ahead and starter goes to starter. The radiator, we'll go to the radiator. We haven't gone into cooling yet, but we will. Alternator clutch goes to the clutch pressure for the alternator. The air manifold, we'll go to the air manifold. I still have to hook a couple things up over there. Fuel manifold goes to fuel manifold. Coolant pump goes to the coolant pump. P-value, all right, that's going to hook to a keypad in a second. Clutch goes to clutch. And we have the RPS of the engine. Now you have a couple nodes here. On any of the crankshafts have an RPS, just pick one. You could do the flywheel. I tend to like to do it right on the crankshaft. That way, if I want to take out a flywheel, it doesn't matter. It's still connected. All right, we can also connect up our engine composite data to engine, and we can hook our seat to seat. All right, now if we hover over the seat composite, it shows us all the values. It shows us that we have our on-offs 1 through 6. 31 is the trigger, 32 is occupied, value 1, the number is value 1, that's AD, 2 is WS, that's where I got the number 2 from for that, value 3 is left, right, 4 is up, down, value 9 is look X, and value 10 is look Y. So if you're ever in doubt, just hover over that with the composite selected and you'll see it. All right, so let's see. We need to add a couple things to our engine here. So let's go ahead and look at it. And so let's look at the top of the air manifold here. So we're going to go real simple. And we're going to go air. And you can connect any of the fluid inlets there. You can hook an air filter, a ram, a scoop. We're not going to do a scoop because that's going to screw up our engine. Again, as the air blows in there, so the faster we go, air blows in, it increases our air volume. And with this system, we cannot, we're not going to automatically adjust fuel, so we're not going to go into that. So I just like to do air filter. You could put a fluid port on there if you want, but I just stick an air filter on there. Sometimes in the rain, I found that this was helping save it from stop running. All right, and the next thing we need is fuel. So the tanks default to diesel, so I just typed in tank. And what I'm going to do is stick this directly on the fuel manifold. Now, you could put piping through there if you want, but I'm just going to stick it directly on there. And as you see, if we click on it, it says diesel. That's what we want. All right, so we should be ready to run here. We have air, fuel, exhaust. I have a duplicate here. Let me get rid of the duplicate. I don't need this on this side. And we should be ready to run minus the battery. So we need a battery. You'll see people throwing enormous batteries like this on trucks. You need something like a small battery. Even in my ships, I'll run tiny little batteries because guess what? If you have good power generation, you don't need tons of batteries. As long as you're making as much electricity as you're using, you're all set. So we're just gonna just go and hook all this up here. All right, so that's all connected, and so we should be good for a start. So let's spawn it. We're not yet. I forgot one thing. One thing was the keypad for the P value. So we're going to type in a keypad right here. All right, and so I'm going to add a couple things right here. So first thing is going to be this keypad. This is going to input our P value, and the second one's a dial. A dial is very helpful for testing and doing tuning work. So we're going to go ahead and put a dial in there, and they're just where I can see them on the seat. Now we need to connect electricity here, connect that to the battery. And now, so the dial I'm going to connect to the RPS, and the keypad I'm going to connect to the P value. All right, so if we remember, I'm going to be able to input a number into this PID, and that's going to make that's going to allow me to tune it. Now, if it's a 0, this isn't going to work. The engine will never start. So this defaults is 0. That's why I need to make sure I put that keypad in. All right, so let's go ahead and let's jump in our seat. And the first thing I need to do is set a value for the P value. So I'm going to go in here. I'm just going to put a 1. Now, 1's probably not going to be right, but we're going to put a 1 in there. Let's do submit, and let's jump in the seat. All right, and so I'll go ahead and press 6. All right, and the engine is up and running. And so one thing you want to note is, because I have a flywheel on there, you heard how long it took to start. Again, an object at rest wants to stay at rest. An object in motion wants to stay at motion. And so I'm just going to change the color on this. The very light colors, they tend to reflect very badly, and so it makes it hard for you guys to see. So the object at rest, the big flywheel and the engine, they want to stay stopped, essentially. And so it takes longer for the engine to start. So I'll show you later when we take the flywheel off that we don't need that. All right, so I have a value of 1 in there, and let's start revving up the engine. So we can see if we look at the dial here, it's at 3.86. All right, so that's around our idle. Remember, I set the idle to 4. All right, if you notice that second digit, it's holding. If I go page up, you'll notice it's changing. What's that? 1, 2, 3, 4, 5 digits down. And now, as you can see, it's even less than that. So it's very stable. All right, it's holding our RPS very well. So I'm going to keep holding the page up key, and I'll start pressing the W key. All right, you hear our engine start to slowly increase. Now, the flywheel is making it so it takes us longer to get this engine started, and that's fine. All right, you notice, remember, I did 1 times 20, or X times 20, so you'll notice we're up around 20. All right, so let's go ahead and let that rev back down. I'm just going to turn it up just to hear so we can hear it. All right, so notice how slowly the RPS comes down. All right, so this would be good for a truck. All right. A truck, you make very slow, deliberate changes. You want that extra mass to help maintain, because you're moving a heavy load. You want to you need a lot of torque. That flywheel helps with torque. Something like a little sports car, you probably don't want a flywheel. Airplane, you don't want a flywheel. Ship, you do want a flywheel. So big, heavy things that you want to stay in motion, you tend to want to use a flywheel. If they need to be dynamic, change speed quickly, like a race car, like an airplane, you don't want a flywheel. All right, so this number's pretty good. So we have a 1 in there. That's pretty simple. It's running. Okay. It's doing everything I ask of it. All right, see, no problems. All right. Pressing W, it's coming up. Letting go of W, it's coming down. Pressing S, it's not going to really do anything. It'll just keep coming down. But, so that's working pretty well. So the value of 1 in there is working pretty well. Now, let's do this. All right, so let's continue to connect this, and then we'll go into no flywheel after that. So let's go into some more elements of this. So let's go on in. All right, so we have an engine that is running. Yay, we're there. All right, and it's running pretty well. We had a p-value of 1, so I'm just going to take a constant number, and I'm not going to hook it up yet because I want to make changes to it, but we'll put a 1 in there. So that's the one number we found out worked pretty well. All right, so we still have some components to connect. We have coolant pump. Now, this one's pretty simple. If you want to make it super duper easy, all you have to do is this, and let's make it super duper easy. We can make it so that it turns on the, we can make it so that it just has a simple 1, right, or a simple value. So if we have 1 in there, what that's going to do is, so I use a constant number. What that's going to do is that's going to make it so that whenever we turn the engine, it's going to give full energy to the coolant pump. It's going to turn the coolant pump as fast as the engine can turn it. Now, we could go a little bit more complex in this. I tend to do that. What I'll tend to do is you could do a PID control on your coolant pump clutch and have it so that it's varying how much pressure to maintain a certain temperature. For example, When we go into stoichiometry, we'll do that. Ideally, you want your engine sitting right around 100. If you're in a boat, you can use raw water cooling, seawater. You can take seawater right in your engine to cool it, and it's the most effective way to cool. But if you get over 100 degrees, you start causing salt deposits in your engine, and it will destroy your engine. So, for example, you'd hook up your coolant system with a PID so that it maintains it at, say, 95 degrees or 99 degrees, and so it never lets it get over 100 degrees. And so it will either give more clutch to the coolant pump or give less. But for this application, we're just going to hook a 1 to it. We're going to start with this on. Now, the other way we can do this is the engine already starts up slowly as it is, right? So we can make it a little bit complex here. It's not that complex. So we'll take a numerical switch box. Now, if the starter is engaged, so right here, if the starter is engaged, now remember, the engine takes longer to start because we have the flywheel on there, right? Well, so that's giving us resistance, all right? The object at rest wants to stay at rest, and so it's resisting the engine trying to start moving the flywheel. Well, the same thing with the coolant pump. That's offering resistance, and so on start, we want as little resistance as possible. That's one of the reasons why our regular clutch will not be engaged on start. And so the other thing we can do here is we could go, when this is started, we want a 0 value. So it will default clutch to 1, but when it's starting, it will default to 0. So that coolant pump will go, that coolant clutch will go like that. Now that's going to kind of jam it on, but that's fine in this application. So that is connected now, the coolant pump. All right, the radiator. The radiator, we can just hook up really quickly to here. So when we turn on the engine, we can have the radiator come on. That's going to start us up, and that's going to start cooling the coolant. Now, I tend to go into more complex systems here, let the temperature come up. I don't want the radiator on if I'm not where I want my temperature to be. See, so the alternator clutch, let's get into the alternator clutch. I want to get this engine kind of finished, and then we can move on from there. So what I'm going to do is I'm just going to copy all this stuff from our PID. All right, and so that's going to come over here. So our PID's over here, and we're actually going to connect. Let's connect this value of 1 to the proportional gain, and we're going to use this new p-value down here to tune our alternator. All right, and so again, like I said, you can use a tiny little battery and have it power a huge ship as long as you're producing as much electricity as you're using. You don't need tons and tons of batteries. Now, you use them for redundancy, use them for backups. If you burn one down, you have charge and discharge rates. We're not going to go on all that, but we'll go ahead and we'll get working on this. So some people would just put a 1 in here, so you're producing electricity all the time. That's fine, again, but it offers resistance. And so what we're going to do here is we're going to add some nodes. So we'll go back up here, and we'll add battery. All right, so number input, battery. All right, so now you're going to read your battery. And so your battery is going to be your process variable for your clutch for your alternator. All right, and so I go in here and I put that in my process variable. Now, what do we want our battery to be? Well, we want a constant number, and we want our battery to be at 1. 1 means full battery. 1's 100% battery. So essentially what I'm telling the PID is, hey, I always want you to keep my battery at 100%. It's going to read the battery. Okay, the battery we just started, it did a bunch of electrical drain. We turned on a bunch of our headlights. The battery drained down to 80. Well, it's going to say, okay, give me more and more and more and more clutch until I'm making enough electricity to start to charge myself back up to 1. As we get closer and closer to 1, it's going to give us less and less clutch, less resistance on the engine. All right, so that's what we want. And so we're going to go ahead and I'm going to hook this p-value in here. And we'll tune that as well while we're there. All right, we'll go ahead and this will start when we do the engine. All right, that will turn on the PID. This will, so what we'll go ahead here is we're going to go ahead and clamp this. Now, this just keeps the number from running away. So we'll just do 0 to 1. The clutch will go to 0, will go to 1. It does have a dead zone, but that's fine. That dead zone will actually help us when we're starting the engine, so it's not on full clutch. All right, so now we'll be able to tune this alternator with that as well. So that's going to charge up our battery. And we'll worry about clutch in a minute. So let's go ahead and update that. And let's connect that node. So we want to go, where are we at here? Battery right here. And we're going to hook it to the battery node, and that's going to do our charge. So let's go ahead and start it. All right, so we're in a driver's seat. Let's press 6. Yep, I don't need to enter in the keypad because remember I put a 1 on the P value. So there it goes. All right, so you notice once we got up above 2.5 RPS, it shut the starter off for us. The starter would be constantly on if we just had it on and on off. So that's now up around 4. Now I could tweak the P value a little bit more to get it closer, but it's working fine. Let's press W. As you see, it revs up. You can hear it rev up. You can see visually it revs up. All right, but it's slow, and it should be slow. We have a tiny little engine turning a big flywheel, and that's why it's going to be slow. And in a second here, we'll go into, we'll remove the flywheel, and I'll show you the differences. Again, you can't just expect to take an ECU off the workshop, plug it into any engine, and have it work perfectly. You have to tune it. One of the great things about this game is that you have to actually go into this engineering stuff and do it yourself, and it allows us to create some amazing things, but it's a challenge to start with. All right, so let's go ahead and we're going to tune the alternator. So let's look at our battery. And as you can see, we're not burning a ton of electricity here. But what we can do here, so it's going to be hard for me to test it. Let me quickly put some stuff to burn some electricity. So what I'm going to do is just quickly put on a motor. And so don't quite know how much to do on this. So I'm just going to do a quick pink motor. That will tell me to delete it here. And I'm just going to go ahead and I'm going to plug that into the battery. And I'm also going to take a throttle. And I'm just going to hook a throttle to this. And that will allow me to control this motor. And the motor's job is just to kill some electricity for me. That's its only job here. And so I'm going to be killing electricity. This simulates me putting on a bunch of lights, turn signals, all that stuff that's burning down electricity. I could just throw a bunch of lights on, but I want to do this just because it'll be a little bit quicker. All right, so let's go ahead and spawn this. And we're going to go ahead and let's start the engine. All right, so you notice it killed a little bit of our battery to start with, the same amount as last time. Now let's just add a little bit of... All right, so see how it's dropping battery? So see how the electricity there is going down? See how the electricity there is going down? So let's keep going down. All right, so you see how it's dropping? It's not dropping a ton, but it's dropping a little bit. All right, so now what we can do is tune in our alternator. So we look at our alternator. You notice that the clutch pressure is 0, so the alternator is producing 0 electricity. We're only losing electricity. Well, now let's start putting a value in here. So let's start with the same number we started last time, 1. And let's watch this. So notice the clutch pressure is increasing. All right, it's trying to put enough clutch pressure in there to generate enough electricity to charge us back up. Now, at idle, we're not producing a lot of charge. The engine's not spinning very fast, so it can't spin the alternator very fast, so it can't produce a lot of electricity. All right, so now let's rev up. And I can also watch my battery here. If I do page up, you'll notice we have electricity. Now let's start revving up. All right, so you see that my RPS is going up. That's turning my alternator more and more and more. All right, so I'm actually going to trim that in. So I'm going to hold the Alt key, and that's going to allow me to maintain. It's going to keep my foot on the floor here. You'll notice we're still losing battery. All right, so if we're still losing battery, this number is too small, so we're going to double it. You don't always double it, but we're going to double it here. Now look at it. We're building electricity. All right, so you notice how the number is climbing on the right. So a value of 2 on the alternator gives us enough to build electricity. Now, as we get closer and closer to 99, watch it go down. So I'm going to go ahead, I'm going to push this off, and now watch it. As we get up to 99% battery, see the clutch pressure is automatically decreasing. So as it gets closer to its goal of 100% battery, it's going to decrease the amount of clutch it needs. So we'll slowly get charged, and it's going to maintain it. Now, what's that doing? That's taking the extra resistance off of the engine so that we're not wasting extra energy. So instead of building a big engine that's like you see people do this all the time, they'll just jam a generator on their engine and they have it always full clutched and it's just always producing more electricity than they need. That's fine. You know, we don't have real consequences in game with that. But to make it more efficient, you can have it automatically clutch the generator. So you notice how the clutch pressure keeps decreasing and the battery is still going up, up, up. And that's because we have this tuned properly. So what's my value? 2. All right, so let's go in there. All right, so let's go in the ECU here. And let's go ahead down to the alternator clutch. And so the p-value of 1 that we put on the engine isn't enough. 2 works for this. So we're going to go put that in as a p-value. And now we have our p-value tuned. Okay, good. All right, so let's go ahead and I'm going to save this. So let's check coolant really quick. So coolant pump. So I want to check my cooler. My cooling system was not on. So if 6 is on, the radiator should be on. Let's see. If we're less than... So that's starter. So if the starter is on, I want a 0. Coolant pump. Let's do one more test here. I want to see something was screwed up. My radiator never came on. Let me check it. It probably isn't plugged in. No, it's plugged in. It's right there. All right, that's radiator, starter. Okay, let's go ahead and spawn this. Now let's press 6 and see if I can't get this radiator to turn on. So I want to check my cooling system as well. So let's press 6. All right, why? All right, so the fan is true. Okay, so the fan's on. It's just not animated anymore. I think some of them, they're animated. They may have taken it out for so it's not as taxing. But you know, so you can see the fan came on. All right, so the next thing we want to check is let's check the clutch. So the clutch is at a 1. So it had 0 clutch when we started, and now it's at 1. It's pumping through. So if you look, you have fluid in and out. Again, look at the cooling video. You can see I do a bunch of different examples of how to cool an engine like this. All right, and so that gives us that. So let's go ahead and let's get back in, and we'll be done here soon. And so I'm going to go ahead and I'm going to copy all this. All right, and so let's save this. Let's save this here as basics mod engine tutorial. All right, we'll put W flywheel. All right, so that's with a flywheel. All right, so let's save that. Let's save this one as I should put no flywheel. All right, no flywheel. All right, let's save that. All right, so this one's going to be without flywheel. So now I want to show you the difference between having a flywheel and not. So remember, what does the flywheel do? The flywheel gives us a big mass, right? That object, that mass wants to stay still or it wants to stay in motion. So an object at rest wants to stay at rest, object in motion wants to stay in motion. So it adds mass to the engine, so it takes us longer to start. And you noticed how slowly we were able to change our RPS. It took us a little while to change our RPS, right? That's not going to be good for a sports car, right? You're not going to be able to change speed very fast, but it's good for a truck, right? It's good for a boat. It's not good for an airplane. So things that need to be able to change the RPS quickly, you don't want a flywheel, or you don't want much flywheel. Things that you want to maintain their RPS, you're going to want to use a flywheel. So went ahead and I'm going to delete out the flywheel. So we need to go in here and we need to check our p-values are going to be off. Now the alternator is fine. The alternator p-value is set. That's good. But watch that our engine p-value is going to be wrong now. So I have it set at 1. So we're going to start with 1. We'll see how it behaves. All right. And this is, again, why you get people who they'll take an ECU off the workshop and they'll say, I hooked it up right and my engine doesn't work. Well, your engine is probably different than theirs unless you use the same engine. You know, you have different mass, you have different number of cylinders, and all these things come into play. All right, so let's go ahead and let's put a 1 value in there. All right, 1. And that's what the other one was. And let's go ahead and start it. All right, see how quickly it started? It wasn't a start. It started instantly. Let's shut it back off. See how quickly it loses RPS? This thing will be stopped in no time. Let's start it again. See how it instantly starts? That's because the starter isn't having to move a huge mass. There's not a lot of resistance. All right, now, remember how slowly that engine spooled up and spooled down? I'd hold the W key and it would take a long time to get to 20 RPS. Now let's watch this one. I'm going to press W. instantly there almost. You know, maybe a second to get up there. Now, let's look at the needle. So I actually kind of screwed this up. Let me do this here. So I want this dial where I can see it. It's not really very visible to me. So let's move this here. It's kind of blocked by the steering wheel. So let's go ahead and cut this. And I want to move this so that I can see it. So let's stick it right there. All right, now let's spawn it and let's look at it. And so, again, I always like to hook up a dial when I'm doing my PID tuning. This is one of the easiest ways to do it, so let's go ahead and start it again. Okay, I have to put the 1 in. I didn't put the 1 in. So you notice we have a 0 in there, it won't run. It almost instantly started. Now watch that needle. See how the needle's dancing? Again, it's very light. There's no flywheel. So that object in motion wanted to stay in motion. Well, now because it's light, it's oscillating. So our p-value is too high. If you see oscillation like this, p-value is too high. Let's press W. See how the needle's dancing all over the place and it's crazy? We want our needle to be smooth, right? So let's go in there and let's go ahead and we will, let's actually do this really quick. I'm going to change this. I'm going to index this gauge. So we have 0 RPS up to 20 RPS. All right, that's where our clamp is set. Well, it's set to 3 to 20, but we'll put a 0 on there because 0 will show us when the engine stopped. All right, so let's put a 1 in the keypad for our p-value. It's sitting at 0. Let's press 6 to start. It sits up there around 4, but notice it's dancing. Let's press W. See how it's jittery? It goes up, down, up, down, up, down, up, down, up, down, up, down. That's because the p-value is too high. So what I'm going to do here is I'm going to hold the Alt key, and I'm going to put the throttle all the way 100%. And now I'm going to start. Now, again, that tells me my p-value is too high. So let's go ahead and make it smaller. So let's go 0.5. See, it's better? Let's go half of that. So let's do 0.25. So see, it's even better. It's not shooting over 20 anymore. Remember, it was overshooting 20, but notice it's still oscillating. Let's go half of that, so that would be 125. Bingo. Look at that. Solid as a rock. Now let's take off the, trim. I'm just going to trim it to 0. Now we're going to need to make sure, we need to do a couple things. We need to make sure that doesn't go all the way down to 0 or the restart. So you notice it's holding at 2.8. All right, that's fine. Now let's press W. See how smooth that is? That's a properly tuned PID. Now we could probably go a little bit higher. Let's go to 0.135 because I want this. And now notice the idle went up, right? It was at 2.81. It's now at 2.9. So that will allow us to get a little bit closer. Make sure it behaves itself. Now, it's because our p-value is low, you notice it's not going to get all the way to 20. That's pretty simple. We go back in there, make it 25, and it would then get to 20 probably. We can also increase that, but notice we have nice, smooth engine. Now, notice how quickly we can change our engine value. That's if you don't have a flywheel. Again, the engine's more dynamic. We want to slow down, we can really quickly. We want to speed up, we can really quickly. Good for a race car, good for an airplane. Not great for a truck, not great for a, a ship. We want a flywheel on ships and trucks. We want no flywheel, generally speaking, on race cars. So if you put one in your race car with a flywheel and you're like, oh, I can't accelerate very fast because you have a flywheel. You can stay at that speed very easily, but you're not going to be able to change dynamically. Look at how quickly I can change speed on this engine. All right, so we have a properly tuned PID. Let's remember our number was 0.135. Notice our battery is also charged up there. All right, so let's go ahead here, and we'll grab it. And now we're going to make this 0.135, and we'll connect that to a p-value. And now our engine is tuned. So, quick recap in this video. We went through a standard flywheel engine. We went through a non-flywheel engine. We went from starting from the basics, got it all the way up to running. I will include in the description my cooling tutorial showing you the different flow rates, the best practices on hooking up a cooling system. Some of them are more compact but less efficient, but that will allow you to build some cars and stuff. The less compact, you might want to put in a ship or something. I'll also include the link in the description to my auto clutch tutorial. I'm not going to go over the auto clutch again. You know, some people just click it on with a 1 value. That's wrong. The whole point of a clutch is gentle application of power. So go check out the auto clutch tutorial and the cooling tutorial. They'll be linked in the description again. And you can see those, and you can utilize those to continue working on the engine. This will come out more parts I'll add to it as we get there. We'll go into stoichiometry and whatnot. So I hope you guys enjoy this. I hope you found it informative, and I will see you in the next one.